Hi there. This is my first elementary video on robotics, and in this video I'll be explaining you three elementary parts that are there in all robots. One is the power supply, the second is the connecting system, and the third is the loop. Starting off with the first part, the power supply. Over here you can see is a heavy duty battery which is also rechargeable. These batteries have got massive current drain. So they can drive heavy loads, for example, a powerful motor or some other heavy duty motor, for example, a servo motor or a stepper motor. And over here you see these are commonly available triple phase cells. They are rated at 1.5 volts and they usually have low current drain, usually used to drive lighting systems, for example, LEDs or microcontrollers or maybe sensors. So there are a few important things that you need to know about these parts. One is, whenever you're using a heavy duty battery, never short the terminals. And the second part, you should always know that red over here or a plus indicates the positive terminal and the black indicates the negative terminal. Okay. In case of a pencil cell, you need to know that, or a AAA cell, that's a pencil cell, you need to know that the longer or the raised terminal is for positive, which is usually indicated on the cell over here, and the flat terminal is the negative terminal. This is applicable for this particular cell also, the small one. These are usually rated at 1.5 volts and heavy batteries are usually 9 volts, 12 volts or beyond. There are other batteries also available, for example a 9 volt cell. We will be talking about them in detail in a video that are only for the batteries. Okay. Coming to the connectivity part. Over here we have three things to demonstrate. One is a male-to-male wire, which is color-coded. The second is normal wire, which is non-color coded. And the third is a breadboard. Okay. The breadboard is the most important part of using all kinds of robots, because it's very easy to prototype a circuit on this. Let me explain you why. If I have these two wires to connect, if I never had this breadboard, I would be just holding them and twisting them or doing anything for soldering, something like that. But with the help of the breadboard, I can easily connect them. Now to explain this thing, let me tell you a bit more about this breadboard. These terminals over here in a row are shorted. Over here, you can see. All these terminals are shorted in a row. So if I need to connect these two wires, what I do is simply put this end over here and this end over here, and these both get connected. So I never need to twist it. And for this particular case, this is just the opposite. These terminals in a row are shorted or connected. You can see at the back. Over here it's not much visible, but these are interconnected. So if I need to connect these two wires over here, what I do is put this wire here and put this wire here. Okay. This also means that there is no point connecting in this manner, in the same row, because they are already connected to the back. And similarly over here, there is no point connecting these two terminals or any one hole in this row to another hole in this row. Okay, let me put this back. Now, coming to the normal wire, this is a male-to-male wire. This is easily available on websites like dx.com, where these are usually used to connect things on a breadboard. You can easily put these wires in a socket over there. Now coming to the load part, we have two loads to demonstrate over here which are very common, an LED and a motor. Coming to the first part, an LED. As I told you, LED works on low currents. And usually LEDs of this size are rated at 3 volts. If you increase the voltage, you're going to kill the LED, and if you reduce the voltage, it's going to be underlit or not even lit. Coming to some specifications. An LED has got two terminals. One is the longer terminal and one is the shorter terminal. In case of LED, you need to remember that you have got to connect the longer terminal to the plus and the shorter terminal to the minus. If you switch the terminals, you're going to kill the LED. It's very important to remember that. So the longer one or the anode goes to the plus and the shorter one or the cathode goes to the minus. So putting it back. Okay. Over here what I have is a motor. Now this is a low RPM motor and you can easily recognize them with a big chamber in front of a normal motor. This has got gears to reduce the speed of this motor and eventually increase the power also. In the subsequent video I'll tell you how that happens in the gear train video. So in this case, this motor is rotating at a very high RPM, but the shaft over here rotates at low speed, so that it's got a lot of power. Now this is a heavy duty appliance, you need to plug it to a heavy duty motor. Now I'm going to demonstrate you these two parts by switching them on. Okay. Now firstly, before I switch on this LED, I'm going to tell you what this is over here. I'll be explaining in detail in the subsequent videos, but for now, let me explain in short. This over here is a voltage regulator. Now as you know, this works at 3 volts and this is at 12 volts, we cannot directly connect them. Otherwise I'm going to kill this. So what I put is a voltage regulator that steps down this voltage to 3 volts. Now these are 3 terminal devices, as you can see. It's got 3 terminals, one at the leftmost, one at the rightmost. The leftmost is the positive terminal input, and the rightmost is the positive terminal output. So if I connect this red wire coming from this battery to the leftmost terminal and the output red wire to the LED and the center terminal, that is the ground terminal, to this minus and that center terminal to the minus of the LED glows and it gets a 3 volt output instead of a 12 volt output. Repeating it, the center terminal is common, which is the minus terminal, which is connected to the battery as well as the LED. And the leftmost terminal takes the positive input, the rightmost terminal gives the positive output. So we have limited the voltage, but one more important thing is that since this is a heavy duty battery, it's going to give a very high amount of current output. So we need to reduce that. We put a resistor to resist the flow of current in the circuit so as to prevent this LED from dying. Okay? Now I connect these 2 terminals and you can see the LED flow. Okay, this is out. As you can see, the LED glows perfectly. My hand is obstructing it. Okay. So now I'm going to connect the motor. Now since the motor is a 12 volt heavy duty motor, I need not use this circuit. So I'll take out the terminals from here and connect them to the motor. And in case of motor, you need not worry about the terminals, because switching the terminal will reverse the direction of the motor. So these wires are not color coded. Connecting these terminals, you can see the motor rotates. You can see it rotates. It's a very high RPM motor, so the shaft will be rotating at lower RPM because the reduction is very high over here. Okay, so that's it. You know, a motor, an LED, connecting system, for example a breadboard and wires, you know how batteries work, you know how to connect them, you know the terminals, and rest we learn in the coming videos, so stay tuned. Thank you.